Hello, students and parents. Today we are going to talk about two-dimensional and three-dimensional motion. So far, we have seen about one-dimensional motion. We have seen the equation of kinematics for one-dimensional. So today's session is about two-dimensional and three-dimensional motion. This is just a basic understanding session. Details we will see in the subsequent session. So let's proceed. We have understood so far that a 1D motion is a motion in a straight line. That means the motion can be in a straight line, either horizontally, vertically, or in an inclined plane, but they are all in a straight line. Now, 2D motion, if I want to consider 2D motion, then if I have a particle moving in this fashion, then it is obvious that I cannot represent the motion only in a single axis. If this is the x axis, then I will not able to represent the motion of this particular particle only along the x-axis. So I will need another axis, which is the y-axis. So when the motion of the particle is on a single plane, this is called a single plane. Single plane is a single plane where both the y and x-axis on the single plane. That time the motion of the particle is said to be in two-dimensional. Now, what about three-dimensional? In three-dimensional, we'll have three axes. We'll have the y, we'll have the x, and we'll have the z. So these are three axes, and all of them are mutually perpendicular to each other. So the motion of the particle will be somewhere in the air. It's like a it's like a cuboid. It's like a cube. It's within the cube. If you can imagine, if you can imagine, this is a cube, and the particle is moving inside the cube in all the three axes. So the position of the particle is is represented over y-axis, x-axis, and z-axis. Now let's go to the next part of 2D and three-dimensional motion. Let's understand in little more depth. When we take two-dimensional motion, we take the y-axis, we take the x-axis. Now when the particle is somewhere in the plane and now it is moving, it is taking a curved path. We observe when the particle is moving, its projection is also on the y, its projection is also on the y, and its projection is also on the x. As it comes here, the projection can be taken on y and can be taken on x also. And for different position, you can take the projection on both the axes. Okay, at this point also, you can take the projection here. Now, if you can visualize, if we just ignore this part, if you just close this part, by just moving the projection, by just moving the projection along y and along x with respect to time, then you will get the motion of the particle in this curved fashion. So basically, what we are saying is motion of y with respect to time is plotted, and another plot is of x with respect to time. So here time is the common axis for both y and x. This is for two-dimensional. What about three-dimensional? So three-dimensional will have three axes. This will be y, this will be x, this will be z. So the motion will be on every axis. So we have to take individually the motion of the particle in the y-axis with respect to time then the motion of the particle in the x-axis with respect to time, then motion of the particle in the z-axis with respect to time. We have to plot with respect to time in all the three graphs. Okay, this is the y coordinate, this is the x coordinate system, this is the z coordinate system. So let's proceed further. Apart from this, let us see further into the next part. When we get into the next part, how we can define the position. We'll see at how we can define the position of the particle in the two-dimensional and the three-dimensional motion. So this is the basic of two-dimensional and 3D motion. So what we have learned so far is in two-dimensional motion, we have y-axis and x-axis, and this can be represented as a y versus time graph and also x versus time graph. So time is the common variable, and in a three-dimensional motion, you'll have y, x, and z. So this will be represented by three different graphs with respect to time, because the motion of the particle is with respect to a common variable called time. So y with respect to time, then you'll have x with respect to time, and then you'll have z with respect to time. So this is all about two-dimensional and three-dimensional motion in comparison with the one-dimensional motion. We have also studied in one-dimensional motion the kinematics equation. So now in 2D and 3D, will those kinematic equations be of any help? So we will see this going further. So see you in my next class. Like, share and subscribe.